Hi everyone, it is Sridevi, Professor of Department of Electronics and Communication Engineering, Yogini College of Engineering and Technology. In this video lecture, we are going to learn about vestigial sideband generation by using filter method, also Hilbert Transform, pre-envelope and complex envelope for AM techniques. Communication Engineering, Yogini College of Engineering and Technology. On completion of this part, the students can able to understand the concepts of Hilbert Transform, pre-envelope and complex envelope. So first, Hilbert Transform. The definition of Hilbert Transform is: consider one signal x of t that is determined in time domain. Here the phase angle of all components of the signal is shifted by plus or minus 90 degree. Let the signal represented x of t with x cap of t in Hilbert Transform. In signal processing, we often need to look up the relationship between real part and imaginary part. If x of t is represented in time domain and x of f is represented in frequency domain, the relationship between real and complex parts of the signal is determined by Hilbert Transform. Let we have I and Q as the components, I be the in-phase component and Q be the quadrature components. The role of Hilbert Transform is given by this block diagram. Let G of t be the input signal and we have two parts, upper part and lower part. Upper part we have one multiplier and similarly in lower part also we have another multiplier. In the upper part, the multiplier multiplies the input signal G of t and one cosine component cos Fc of t. Similarly, this cos Fc of t is given inside the Hilbert transformer and it will get 90 degree phase shift, so that it will become a sin FCT. This sin FCT is given as one of the input of the multiplier which is situated at the lower part. The another input is nothing but G of t, which is the input signal. So upper half will be the multiplication of G of t and cos FCT, and lower part will be the multiplication between G of t and sin FCT. So after multiplication, it is the multiplied output is given as a low pass filter in case of both upper half and lower half. This cos FCT is generated by one oscillator circuit. The output of the oscillator is one cosine component which is given as directly to the upper component, and it is given as Hilbert transformer, and it is converted as sin FCT to the lower part of the multiplier. So now the output of low pass filter will be upper part will be in phase component and lower part will be the quadrature component. In phase component is represented by 1 by 2 into I and quadrature is represented as minus 1 by 2 into Q. The Hilbert transform shifts the phase angle by plus 90 degree and negative frequencies by plus 90 degree and positive frequencies by minus 90 degree. That is why we can say all the positive frequencies are shifted by minus 90 degree and all the negative frequencies are shifted by plus 90 degree. So for this reason, Hilbert transform is also called as 90 degree phase shifter or quadrature filter. So cos is generated as input and it is given as the Hilbert transformer. Afterwards it is converted as sine. So the Hilbert transform in time domain is represented as G of t, and the signal is represented as G cap of t after getting Hilbert transform. So G cap of t is 1 by pi into integral minus infinity to infinity G of tau by t minus tau into d tau. So x of t and x cap of t both are x of t is the Hilbert signal which is given as the input of Hilbert transformer, and x cap of t is the signal which is after Hilbert transform. X cap of t is represented as 1 by pi into integral minus t infinity to plus infinity x of k by t minus k into dk. So simply we can say Hilbert transform which gives plus 90 degree phase shift to all positive frequencies and minus 90 degree phase shift to all negative frequencies. So simply it is determined by a change or only change in Hilbert transform performs the signal that is change in phase. So 90 degree change. These cosine and sine wave properties are given here. Cosine wave is started as maximum and sine wave is started as 0. So here the cosine wave and sine simply the cosine wave is converted to sine wave. There are two way of conversion. One is time domain and another one is frequency domain. So to convert cosine into sine, some different steps are there. So plus 90 degree phase shift will be noted as plus q, and minus degree phasor that is represented as minus q. So spectrum is represented as S of t is equal to 1 by pi t that will produce the output as S cap of t. So here we have one signum function, SGM as signum function. So the term SGM stands for signum function, that is f of 1 by pi t is equal to minus j signum f of x, that is the signum function. So the Hilbert transform have the property as x of t is the input signal and x cap of t as the output signal. Both x of t and x cap of t having the relationship as both are orthogonal. So x cap of t can be written as minus x of t. So Fourier transform x is then Hilbert transform also x is for energy and power signal. These are the basic properties of Hilbert transform, and we have one quiz question now. So one set of question is that what kind of filter is an ideal Hilbert transformer? Low pass, high pass, band pass, all pass. The answer is all pass. So the explanation of this question is an ideal Hilbert transformer is an all pass filter. This is one basic important quiz question. And another one question here, how much phase shift does the Hilbert transformer impact as the input? As from the definition we know it is a 90 degree phase shifter, that is the given input signal which is represented as cosine will be converted as sine, so that it is a 90 degree phase shifter. Hope you all understood this session. Thank you.